Okay, let's do the 2023 10A problem 11, also the 12A problem 9. For the AMC 10, this was the first one that I took more time than I should have. I made a couple of calculation errors and had to restart, and then I had to check it again and had to restart again. And so I lost probably 2 minutes on this problem with silly calculation mistakes trying to go quick. So let's talk about how it goes. A square of area 2 is inscribed, that's this one, inscribed in a square of area 3. Creating 4 congruent triangles as shown below. What is the ratio of the shorter leg, let's call this A, to the longer leg, we'll call that B. And it said that they're congruent, correct, congruent triangles. So this would also be A and B, this would also be A and B, this would also be A and B. And so our goal is to find A over B. Now, there's a number of ways that you can get some equations out of what's going on here. The first thing is that we should be able to know that since the area of the inner square is 2, then this must be the square root of 2 on each edge. That would mean that A squared plus B squared is equal to 2 by Pythagorean theorem. Next, what can we say? The outer one had a square of area 3. That means its side length is the square root of 3. And so we could say that A plus B is the square root of 3. Furthermore, we know the difference in their areas is 1. And I can take this triangle and make them into a rectangle, which is how I like to do those because it goes a little faster. And since it's a rectangle, its area is just AB, and these can also make one, and you're going to have 2AB. So we now know that 2AB has to equal the difference in their areas. 1, we'll go ahead, you could cut in half. Let's go ahead and do that also. AB equals 1/2. I'm seeing lots of options right now. We've got this if we square it. It's going to have one of those terms. We know what A squared plus B squared is. Let's start going to town and trying stuff. We don't know, right? You just got to kind of see what's going to happen. You have a lot of ideas. They're probably going to bear fruit. I'm going to square this one and get A squared plus 2AB plus B squared equals 3. Then A squared plus B squared is 2. We've already kind of found the information that we're going to get from that, so that's not going to help us. Let's think about what else we can do. We're looking for A over B, and we know that we have AB equals 1/2. What I like to say is create what you want. If you want A over B, then make it. So I'm going to go ahead and divide by B squared, and over here multiply by 1 over B squared, because that's going to give me A over B on this side, and now we might start to have some ideas. So I've got A over B is 1 over 2B squared. If I could just find B, or B squared, then we would find our answer. So, what can I do with that? Well, what if I had just divided by B instead of B squared? Then I would have had, since AB was equal to 1/2, if I had just divided by B, I would get that A is 1 over 2B. So if A is 1 over 2B, maybe I could plug it into here or here and try to solve that equation. Because we're looking for B squared, I kind of think it might go better in here, because then I'll have B squareds running around. Let's see what we got. If I plug 1 over 2B here, you're going to get 1 over 4B squared plus B squared is going to equal 2. Now I'm going to immediately multiply by 4B squared. I'm going to come over here to do this work. So I'm going to have 1 plus 4B to the 4th equals 8B squared. Let's move the 8B squared to this side. So we'll have 4B to the 4th minus 8B squared plus 1 equals 0. Okay, but now we got 4th power running around, but maybe we could just think about it as B squared could be the letter U. We'll do a U substitution, knowing that we just want I usually use u from calculus. You do a lot of u substitutions there. So b squared, u is the same thing as that. So if I can just find u, I would plug it in and we'd be done. 1 over 2u is now our answer as well. So I'm going to make this 4u squared minus 8u plus 1 equals 0. And you might wonder, well, does that factor? Doesn't look like it's going to factor that well. Maybe it does, but maybe we could do something. We got this 4 and the 8. Why is 8 a multiple of 4? Is it a clue? I don't know. Let's just divide by 4 and see what it looks like. If I divide by 4, it's going to say u squared minus 2u, and I'm going to automatically move negative 1/4 now to the other side. It's actually 1/4 to the other side, but now becomes negative. That looks like we want to complete the square. And so we're just going to add 1 and add 1. And what that gives now is u minus 1 squared equals 3 over 4. So if I was to square root, I'm going to get u minus 1 equals plus or minus. Probably couldn't be minus, could it? I don't know, let's put plus or minus for a second. You're going to get root 3 over 2, and then you're going to get that u is equal to 1 plus or minus root 3 over 2. Now let's think about what root 3 over 2 is. It's about 1.7 over 2. So you're less than 1 right here, which means you could technically subtract it. We've got 1.4 here. If I added 1 plus 1.4 being about root 2, good idea to memorize the approximations of those two. They come up a lot and it helps with reasoning as we're seeing right now. So if I did 1 plus 1.7 over 2, approximation, it's almost 1. You're almost to 2. That would mean, oh, but that's b squared as well. I was thinking it wouldn't work with the side. So I don't know which one it is off the top of my head. I don't know. Let's just see if we can look at the answers. We've got things with root 3 and root 2 and 2 and root 2 and 1. We know that a plus b, we know b squared. Oh, b squared has to be less than 2, but it would be less than 2 because you're adding 1 plus a number less than 2. So maybe it could be. In fact, if you took away this number, it would make b really small. And we know it needs to be about 1.7. There we go. That's kind of what we needed. If we, basically what I'm saying is this. If we took 1 plus about, I don't know, 0.85, you're at 1.85, but if you subtracted it, it would mean that b squared was about 0.15. And that would mean b is pretty small. A would be making up the majority of this, and so it doesn't really make sense. So let's make b the larger one of these two and make it 2 plus, I'm sorry, not b, but u, 2 plus root 3 all over 2, combining them to be one fraction. Don't forget, what is u? U is b squared. So we got that around here somewhere, right here. So since u is b squared, we're just going to plug it in right here. It's going to be 1 over 2 times, and if you think of it instead as times 1 over b squared, what does that make it? The reciprocal of b squared. So if this is b squared, I want the reciprocal of that, which is 2 over 2 plus rad 3. Those are going to cancel. Now your answer, don't forget this is the answer when we get it, is 1 over 2 plus rad 3. Multiply by the conjugate. 4 minus 3 is 1. Beautiful denominator. Numerator 2 minus root 3. Answer choice C. And we are done with this problem. Let's get to another one. Okay, let's do 2023 AMC 10A. Problem number 12. How many 3-digit positive integers n satisfy the following properties? The number is divisible by 7, the number n is divisible by 7, and the number formed by reversing the digits, 3-digit number reversing the digits of n, is divisible by 5. To be divisible by 5, it must end in 5 or 0, but if I reverse that to be n, n can't start with 0. So that means there's only 5 blank blank And all we have to do now is do multiples of 7. I'm just going to do 490, which is 7 times 70. And I'm going to add 2 to that because I know it'll put me in the 500s. 7 times 72 is going to give me 504. Now, how far can we go? You can add 98, which would be 7 times 14. But you're going to go over if you do that. So let's do 7 times 13. And if you do 7 times 13 more, basically you're adding to 72 13 more. You can check that to be sure it is 595. Then how many is this? I just take the multiplier 85 minus 72 plus 1. Answer 14B. Let's get to problem 13. Okay, so we're going to continue now with the 2023 10A problem 13. Abdul and Cheng are standing 48 feet apart in a field. I did spend some time on this question as well before I realized what the mechanism was to draw a confident conclusion in the process. I had suspicions, but I didn't think about how to set it up. So Bharat is standing in the same field as far from Abdul as possible. So you're going to have 48. Let's go here. We'll say A and C is 48. B somewhere, we don't know, as far from there as possible. Something like this. Just rough spot there. So that the angle formed by his lines of sight to Abdul and Cheng measures 60 degrees. So I originally just draw it kind of over here, like you don't know, how far it can be. So I thought 60 degrees, something like that maybe. And, let's just go with that for now. And so then what? All right, what is the square of the distance in feet between A and B? What is x squared if I call that x? So I tried some things. I tried coming over here, and if I did that, maybe I would have to use tangent, but you're not supposed to use tangent. So, or sine or something like that, sine opposite over. But then you'd have this piece, and it just seemed like it was probably not the best plan. So I thought, well, wait a minute, why can't I just go way over here? There's got to be something, some mechanism. So I thought, well, what if I had a circular arc right here, and this was an inscribed angle to that arc? And then that made me think, well, what if I tried, every triangle can be inscribed in a circle, so what if instead of that, what if I made AB? And I had a few of these drawings, and I kind of suspected that wouldn't it be nice if it was 30, 60, 90, right? Where this was 60 and that was 48. But how would I know that? So I started thinking, well, I know there has to be a circle that goes through all 3 points because it can be circumscribed. So I just drew a circle over here, and then if you're going to get a 60-degree angle, it has to cut 1/3 of the circle. So you can imagine an equilateral triangle going like this, and I tried that, and this would have to be 120 degrees, and that 48, and then where could it hit? And so as I'm looking at these values here, actually it's C here and B here. As I'm looking at these values, I started thinking, wait a minute, go back again. What does it say? He is standing in the same field as far from Abdul as possible. Since he has to be standing on the circumscribed circle, the farthest point away is diametrically opposite from A. And because it's diametrically opposite, it forces this to be 90 degrees. And so now that you know it's 90 degrees, I also thought about 7, 24, 25 as an option because that's 48, 1450, 2500 not here though. So that kind of went away pretty quick. Probably would have been good if they put it there just to mess with people, but they didn't. So you have 60 degrees. Probably because you'd figure out it's not a 60-degree angle with the right triangle, of course. And so you're going to use 30, 60, 90. And you're going to say if opposite 60 is 48, opposite 30 is that divided by root 3. Root 3 goes into there 16 times, and you have root 3. Speed mechanics there. So then this is going to get doubled. You're going to get 32 rad 3. So now if 32 rad 3 is here, and I want that's what x is, again, we know it's diametrically opposite. We know that's 90. It must be 30, 60, and 90. There is no doubt. 32 is 2 to the 5th. 2 to the 5th squared is 2 to the 10th. 2 to the 10th is 1,024. 1,024 times root 3 squared is 3. Times 3, 3,072. Let's get problem 14. And now problem number 14 from the 10A. A number is chosen at random from among the first 100 positive integers, and a positive integer divisor of that number is then chosen at random. What is the probability that the chosen divisor is divisible by 11? I did lose probably a minute to a minute and a half more than I needed to try to find the best strategy on how to approach this after you get started. The initial start isn't too bad. It seems like you could, if you wanted to, do probability of A given that B has happened, which is usually written like this. And you could use that formula if you wanted, but I'm kind of not wanting to use that formula. I just don't use it much at all, or never have really, at least on the contest. So from here, I just want to say, okay, if you're going to be divisible by 11 in the divisor, it must have been a divisor of 100 positive integers that's a multiple of 11. Well, there's only 9 of those, 11, 22, 33. So I wrote those down, 11, not all of them, but just a few, and then dot, 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 99. So how many are there? 9. How many integers are in the first 100? 100. So it must be 9 over 100. That is my chance of choosing a number in the first 100 that even has 11 as a divisor. So if I do that probability and then I multiply that by the probability given that I have a number that has an 11 in it. So now it was, well, do I just add up all of these divisors? And then that won't actually work, I thought, because not all of them have the same situation. For example, 11 is 11 times 1, but 22 has 22, 11, 2, and 1 as its divisors, right? And so you're like, okay, well, they don't all have the same number, so I can't just add them all up. And so I thought, I guess I could just individually give a 1 in 9 chance of this. But you know, you sense at that point. You should sense at that point. There's got to be something simpler, some simpler way to do it. I don't want to go through all these cases. So now you have I guess a crossroads. You can take a step back and try to think of what that mechanism is. And this is where I lost a little bit of time trying to find it. Or you can just go through, and I've got a 1 in 9 chance of doing this times the chance I get an 11 here. And so you start to think about it though, if all of these have an 11, let's look at something like maybe 44, right? And I was like, okay, so you got 2 squared times, that's got 6 divisors. Add 1, you got 6 divisors. How many of them are multiples of 11? And you say, well, you've got 11 and you've got 22 and you've got 44 itself. So it looks like 3 out of the 6, and that's 1/2, and that's 1/2, and that's 1/2. And so you kind of think to yourself, is it just always 1/2? Why would that be the case? And it would be this, no matter what this number is, right, 11x, you are going to have to put the 11 with something. So if I broke 44 now, instead of doing it this way where I did the prime factorization, if I wrote it as 44 and 1, 22 and 2, 11 and 4, no matter what I do in every pair of these, for all of them, one of them has to have an 11. And if it doesn't, then you won't get a multiple of 11. And since you're going to have only paired up numbers, we don't have any perfect squares here, then we don't have to worry about something weird happening like a double case. Therefore, no matter what, by symmetry, all of them are in fact 1/2. And once you realize that, you can just tack on 1/2. 2 times 100, 200. Answer B, 9/200. So again, one more time, when you pair up the divisors of all of these numbers, one of them will be a multiple of 11 and the other one will not. Therefore, it's half of every group of 2 is a multiple of 11. Let's get the last one in this set, problem 15. And the final one in this set of rapid fire for AMC 10A 2023, problem 15, an even number of circles, we're telling us this, it must have some value, are nested, starting with the radius of 1 and increasing by 1 each time. If you've done a lot of old tests, I believe this looks just like an AMC 8 problem 25 maybe. Something about Marjorie's art design or Margie or something like that. I'm not sure what the name was, but it was definitely an art design and it looked just like this. And if you did that problem, then you shouldn't have any problem quickly getting adjusted to this one. So, all sharing a common point, the region between every other circle is shaded, starting with the region inside the circle of radius 2. So you start with a radius of 1, it increases by 1. So first one's 1, second one's 2, then 3, then 4. So the first shaded circle here, the one that I'm shading in more now, that's got a radius of 2 and this one has a radius of 1. If I just focus on that, what's the area of just that shaded region? It's 4 pi minus pi, right? 2 squared minus 1 squared. So you're going to get 3 pi plus, okay? So that's what we're doing. An example showing 8 circles is displayed below. What is the least number of circles needed? This is just an example. Needed to make the total shaded area at least 2023 pi. They're all going to have a pi, right? So why don't we just stop writing that and just say it's 3 plus? Well, the next one's going to be, we've got 2 squared minus 1 squared, 4 squared minus 3 squared. So if you pay attention in my classes, you would know the difference in consecutive squares is the sum of their bases. So 4 squared and 3 squared is going to have a difference of 7. And it's always going to be the even numbers. So when I go 6 squared minus 5 squared, it's going to have a difference of 11. So you're going to have 11, and then you can just see it's arithmetic. And so why is it not arithmetic? Because 1 is an adjective and 1 is a noun. That's my surmise. I don't know 100% sure, but that's why I've always assumed that why it's pronounced differently. It's an arithmetic series. And so we've got 3 plus 7 plus 11, and we're adding 4 every time. We don't know where we end, but we need it to be at least 2023. So maybe I should come with an nth term rule. Nth term rule is a sub n equals a sub 1 plus n minus 1 times the common difference of 4. That's 4n minus 4, 3 plus. Now I'm going to have 4n essentially minus 1. Okay, 4n minus 1. That is my nth term. So how am I going to get the sum of an arithmetic series? Average of the first and the last will be the nth term. First is 3. So 3 plus 4n minus 1 is going to be, I gotta go over here, I guess, 4n plus 2. And the average of the first and the last would be you divide by 2, and then you multiply that by the number of terms. So we're going to have 2n plus 1 times n. So n times 2n plus 1 greater than 2023. Now, maybe what you want to do here is, try and distribute and move and factor it. It is 7 times 17 squared. 7 times just 117. Not sure you're going to be able to get much luck with that because it just needs to be greater, and we don't know if that's the right number. So I don't know. I just kind of started thinking, if I think about how many terms, this is actually 2 circles. This is the 4th circle, the 6th circle, the 8th circle. So whenever I have a term, I actually have 2 circles I'm adding for that term. The first and the second, the third and the fourth is that 7. So then that made me think my answer here needs to be divisible by 2. Why don't I just try something like 28 circles? If I had half of 56, 28, would that give it to us? Well, 28 times 56 plus 1 is 57, and 60 times 30 would only be 1800, so we're not going to get quite there. So we take 60 and you cut it in half. There'd be 30 would be n then, the n and r calculation, because the n in r's is not the number of circles, it's the number of terms, and there's going to be twice that many circles. Okay, so if I put 30 in here, 30 times 61, again, you're just barely over 1800, 1830 to be exact. And so from there, then what? Well, looks like we might have to try 32. If I put 32 in there, 32 times, 2 times 32 is 64 plus 1, 65. 65, what is that going to be? It's like 140 over 2, but I'm trying to know what that's going to be. I don't know. Let's just do it this way. 32 times 60 plus 5. So 60 is 180 and 12, 192, and then put a 0. And then 5 times 32 is going to be 160. That'll put you at 2080. Okay, but if we had 31, would it have worked out of curiosity? No. If you plug 31 in, you'll have 31 times 63. And if you do 63 times 30 plus 1, you'll get 189 with a 0, which is 1890 plus another 63. You're not going to make it over 2000 with that. 100%. Not that we had to, we already know. But just out of curiosity, it definitely, because it's going to be consistent then. Now you know that you've kind of done it correctly. If 31 doesn't work, my reasoning doesn't have any holes in it. And the quick check kind of reveals that to us. So your n value in this series is 32, but that means there's 64 circles. That's it for this one. I will see you in the next one.